Hi everybody, today we are going to discuss the regression analysis. This is Ahmed Al-Bannam. The agenda for today, we are going to discuss the definition of the regression and examples, and we will go through how to implement or deduct the model. So basically, in a statistical modeling, regression analysis is a set of statistical processes for estimating the relationship between a dependent variable, we often call it outcome or a response variable, and one or more independent variable, often called predictor or covariates or explanatory variable or features. This is the definition from Wikipedia, but in a nutshell, we want to expect or get the outcome of an input or multiple inputs. Like we have x, y, x1, x2, x3, x4, and we expect y. We want the y, the outcome. Okay, so the regression analysis, we can deal with one-to-one relationship x and y, or we can have x, x1, x2, x3, x4 number of inputs, and we are expecting the y thing. So let's talk about example. Maybe it will be easier for us to explain it. So basically, if you can see this pattern, like you see, I have here, this is x and this is y. Okay, so for each value of x, there is another value of y, but I cannot be assured. This is, for example, this is my sample data. I start from here. This is the sample data. This is the range of the data that I have from x naught or x till xn. So from this data, I cannot expect, for example, xn plus 1, right? I don't know how the next x is going to be because I don't have data here. So people were saying, okay, we are going to try to draw a line that this line will have an average way or will pass by most of the income of the inputs, and based on that line we can expect later the output for some inputs that we don't know for now. So if for example I try to adjust a little bit like this is gonna be my regression line. So in this case we call it is a positive regression, like because it's increasing. If we go for another example like this, take the brush again, and I have values like this, and this. I can say this is kind of a negative regression. Sorry, Control Z. If I draw a line here, the line gonna be like decreasing. So in this case, I'm gonna say the regression is a negative regression. In some cases, in some other cases, like in this scenario, for example, if I have the values like this, the output is constant for whatever input I have in x. So this is not a regression. There is no relationship between both of them. I cannot do anything. It's always, so basically these are independent variables. They don't depend on each other. Okay. For example, if the data is like this, scattered like here and there and here and here and here and like this and here, so I cannot draw a line or a relationship for this regression. So there is no dependency. There is no dependency in this case. So people were saying, okay, let's try to create the same thing again, and let's try to derive how to get this line or to draw this line. Don't save. Let's go to one of the here, for example. Yeah, this is one of the examples that we were talking about. So in this case, I need to get the equation of this line. So basically, any equation y equal constant b naught, or let's make it here easier. So yeah, y equal constant b naught plus the slope b1, the slope of the line, plus x is the variable that we are talking about. So this is the equation that we want to build to get this line. So in here we have two variables or two unknowns, which is b1 and b0. b1 for me is basically the slope of this line. So slope of a line is basically delta y over delta x. So basically any points in this line, so delta y is be y2 minus y1 divided by x1 x2 by minus x1. But I don't know any values in this line. So basically what I'm gonna do, I'm gonna get the average between all of the x's and all of the y's, and this average point should be one of the points that achieves this equation of the line. And I'm gonna do the delta between each and every point of this actual point minus the average or the mean, and we will take the sum of all of the delta y divided by all of the delta x, and this is gonna give me the slope of that equation. And from that slope, from this slope, I'm gonna get the b1. Then I'm going to substitute the y and x by y mean and x mean. So I will be able to get the b naught. So let's do this in Excel. It's gonna be easier for us. So I'm gonna pull an Excel file. Here is an example of a regression. I do it by both ways, the least square method and the error square, but we will, for now we will try to neglect this part. We will just work on this, and maybe in the next video I'm gonna explain this also. So basically I have y as independent value, and x is the I have x the independent value and y is the dependent value, so or variable. So I'm gonna get, for this I'm gonna get the average, and for the y I'm gonna get the average too, and then I'm gonna get, as I was saying, I'm gonna get the total, the difference between this x and the mean, and here I'm gonna get the difference between this y and the mean. And then what I'm gonna do, I want to do x minus y minus y1 y mean, or the delta y over delta x. So basically I'm gonna say delta y multiplied by delta x divided by delta x squared. Basically is the same as if I say delta y divided by delta x. So this is what I did. I multiply the difference in y by the difference in x, and then I get the delta x squared, and then at the end the slope is gonna be easy. b1 is gonna be delta y divided by delta x squared. Let me, so you see it is delta x squared. So it's easy. And for b0, the equation is here, as we were saying in that one. So if I want to get b naught, so b naught is gonna be equal y minus b1 over multiplied by x, right? So all what I did, I just took this part and put it in the other side of the equation, and to get the b naught I'm gonna substitute this x and y by a point that achieves the equation of this line, which is the mean points, which is this 2. And this is what I did here. I said y mean minus the b1 multiplied by x mean, and it's gonna give me the B naught. So after doing that, I'm gonna substitute in my equation. My equation is gonna be this is wrong. This was for a different equation. So my equation gonna be minus 182.46 plus 1.475806 divided by x. So since this is our function, so if I want to get any values or any unexpected x, for example, if x, I don't have 178 here, so if I want to get the value of y, if the input is 178, I'm gonna apply this value in this equation, and this is what I did here. I just said B naught plus P1 multiplied by the 178, and I'm gonna get the output. So what I'm gonna do, I'm gonna upload this file in my GitHub, and you can see it in down below here in the description. So you can have the file with all the calculation. All what you need to do the regression is to just put the input and the sample output, and then the whole calculation is going to be calculated for you. Hopefully this was an easy and to the point session. I see you in the next session. Thank you.